Hi everyone, it's Dr. J again. With me today is HM to help us out. HM, you want to say hi to everyone?
Hi everyone.
All right. So we're going to be doing the classic problem of towers of Hanoi, where end disks are put on a peg in order from high to low, from big to small, and they're to be moved to another peg using a work peg to help out, using a spare peg. Okay, a good reference for this is good old Wikipedia. So if you want to look up more facts about towers of Hanoi, I recommend Wikipedia. It's well done there. Okay, let's look at what the outline of the program is going to look like, which we already started the other day. We're going to finish it together now and show the function towers of Hanoi. This is the prototype for the function. You want to read the prototype, HM? Void
Prototype is a void T Henry.
towers of Hanoi.
Tower of Henry
T Hanoi.
is for number of disks, right? And
End,
three sources.
end, come in. So it's reserving 4 integers, right?
Yeah.
Okay. And we also have another helper function that's going to read in data for us. What is that called?
It's pointer, right?
Read that function.
Read that function.
Void read input in pointer, right?
Yeah.
So that's using an in pointer because if we try to read input in that manner by value, passing a parameter by value, it will not work, right?
Yeah.
Okay, so we need an in pointer. Or we could do it by reference. Doesn't really matter. So let's look at the code now. Int main, we're defining our variables. You want to read that first line?
Int n, s1, t2, and w3.
All right, so let's label what they are. S is the source peg, T the target, and W the work or spare peg. I have to shut the phone. Okay, so S is the source peg, T the target, and W the work peg. Good.
And n should be number of disks, right?
And yeah, let's put that as well on the next line. N is the number of disks to be moved. Okay, and we're asking the user for the number of disks in this function read input. We're passing in the address of n. Pass the address of n since a pointer is required. Okay, let's take a quick look at the function void read input int asterisk n. So we ask the user in a cout enter the number of disks to be moved, and we read it in not to n but to asterisk n. We have to read it into what's being pointed to, the integer being pointed to, which is n. Okay, so that's fine. And the name of the function that we call to solve the problem is t Hanoi. And now we pass in the parameters n, s, t, and w. So all we have to do is write the function that does the work. And the work is going to be just writing a line that corresponds to each move of the disk. So if our first move is from peg 1 to peg 3, we should have an output line that says move peg from peg 1 to peg 3. So that's all that this should be doing, a lot of output. So the name is T Hanoi, right? This time we have to give names to our integers. In the prototype we didn't. So what do you want to call them? You want to stick to NSTW? Yeah, why not? We don't have to, but they're fine. They're fine names. NT and W. Okay, now let's get started. First thing we do is we check, are we at the base case? The base case is n equal 1. And in the base case, we simply move from S to, no,
S to T?
yeah,
Yeah, okay.
S to T.
It's
Okay,
also-
now let's, okay. So the base case, we move from S to T. So if we have just one disk,
it's decreasing.
it'll be one step. The base case will take care of it, right? And we'll move from S to T. So if n equal 1, what do we write? C out. What?
It's moving, right?
Yeah, we move from S to T. So C out. Move from,
S to T.
yeah, 1 equals. Move from,
S to T.
yeah, S.
2.
Did I have a capitals?
Yeah.
I don't want a cap. No, that's, how am I doing? S
2.
to T. Okay, and then we're going to test it right here to make sure the base case works, okay? And before we go any further, we'll just test it right in here. So we'll test it for n equal 1. Compile. 1. It should say move from 1 to 2, right? Looks good, right? So far, so good. Everybody with that? We tested it for the base case. So we want to test it again? Let's do it one more time, the base case. Base case is when you're moving one disk, correct? And what the output is that it moves from 1 to 2. 1 is your source, 2 is your target. Okay? So that works fine. The base case is good. Now let's do, we could do an else or not an else. My preference is an else. Okay, so now we have to solve the smaller problem of moving n minus 1 disks from S to W, right?
Yep.
We discussed that on the board. So solve the smaller problem of moving n minus 1 disks from S to W and using the target as the work. So we switch the W and the T.
Yeah.
Now let's write down what we just did. Solve smaller problem.
You were running here?
Smaller problem of moving. Let's go to another line. N minus 1 disks from
S to W.
yes, S to W. Okay, now that we've done that, we have one, visualize what we have. We now have n minus 1 disks completely in order on W peg. We have nothing on the target peg. And we have one big disk, the biggest disk of all, on the source peg. So what we want to do is move that very big disk from the source peg to the target peg. And we know how to do that. That's the base case, right? Moving one. So T Hanoi, just move one from S to target using W. And that's the base case. This is moving one disk from S to T, which is, let me put in parentheses, base case. One can argue that the base case is when you do nothing, move zero disks, but I think we can safely assume we know how to move one. You and I pick it up. If it's not too heavy, we move it. If it's heavy, we get Nehal to help. Right, Nehal? Okay, so that's I think we're safe. Towers of Hanoi. Now we have the biggest one sitting on the target. We have n minus 1 sitting in the work. So we have to take the n minus 1 that's sitting on the work and move it to the target. So the work becomes the source in that case,
Yeah.
okay? So there's n minus 1 disk sitting where? On the work, right? We want to move it to the target on top of the biggest disk.
Yeah.
Using the source as a work disk. So let's write down what we're doing. This moves the n minus 1 disks from the work peg to
You did your little exercises on Excel.
the target
For each exercise,
using
you create a different project.
source
Right? Because
peg
you use different source files
as
and stuff.
source peg as work peg.
Because I started putting
Spare
it
peg.
everything here.
Just create a folder and create it.
Whatever you want to call it. If you look at Wiki, they call it spare peg. But this is the solution, pretty trivial to code, as opposed to the iterative solution that I gave you for homework, which is not so trivial to code, right?
Yeah.
Let's see if this works, however.
Okay, so that's one.
Keep your fingers crossed. Always got to keep your fingers crossed. Uh-oh. I didn't end, what didn't I end?
You only have this class?
Maybe I ended it twice. Let's see. It's always
Oh,
right
sorry.
squiggly problems.
Oh, yeah.
Homework isn't important.
Let's see. This one doesn't have an end? It does. Oh, this one has two ends. Okay. Compiler does that to me. Gives me extra squigglies. Likes me. Let's try moving 3. We know the answer is how many steps? 2 to the third power, take away 1. How much is that? 2 to the third power is
It's 9, right?
8.
8,
Take
8.
away 1. So it should be 7 steps. That's more than 7 steps. It's an infinite number of steps. So clearly that's incorrect. So we have to stop that. Okay, so what it did is it always thinks n is 1 every time we call this. I mean, did we call it correctly? Maybe not. We never asked the question, how many disks to be? Yeah, we did. What did I put in? I put in 3.
3 disks.
So maybe we don't know where the problem is. It thinks it's 1. Why does it think it's always 1? Huh. Work for 1. We're going to pause this while we figure this out. Okay, so we figured it out. we forgot to put the brackets on the else path. Whenever I have a mistake, it's always got to do with brackets. 99% of the time, braces, brackets, whatever you want to call it. All right, because on the else path, all three of these have to be done. Without the squiggly lines, only one of them would be done, right?
Yeah.
All right, so let's try running it, compiling it, and running it. All right, let's try moving 3 disks. It should be 7 steps. That looks right. And whether the steps are right or not, we're not sure just yet, but it looks reasonable. Let's try running it with 4. We should get 16 steps.
15.
15 steps, right. Okay, that's good. So now let's try numbering the steps. So put in some kind of global counter or something. So let's add a global counter and we number it so we see exactly how many steps we have. So int counter equal to 0. And every time we do a cout, we'll increment, actually within the cout, we'll put in the counter and increment it. So where's the cout? Right here. This would be the only place that we write, so it would be in here. I'll put a 1 colon right in here, right? So counter colon, counter plus plus, colon, colon, and then I destroyed the rest of the syntax. That looks syntactically correct? Think so, right? Let's try it. Compile and run. First for 1. Uh-oh.
1 to 2. 0.
Yeah, so I have to do plus plus instead of plus plus before the counter. Okay. So instead of here, we do pre-increment, right? Plus plus right in here. Should fix it. Try that. Let's try 1. Okay, now let's try 3 and make sure it numbers all of them. 3. That looks good. Steps 1 through 7. Now let's try 16. I mean 4. We should get 15. Yes.
Yep.
And let's just pick one big one. 7. 2 to the 7th power. 2 to the 8th power is 256. Go with 8. 255. Perfect. Perfect. Okay, so I mean, the steps are logical, so I'm sure these are the right steps. And we're done. Any questions from the peanut gallery? Okay, so like any other program, if you're not careful when you're coding it, you can get a little bug here or there, which is usually pretty easy to debug. And that's what happened here. We had a little problem, took a minute or two, and we debugged it. Thank you very much, HM.
You're welcome.